You step into a metal box, press a button, and effortlessly glide dozens of floors up or down. But have you ever paused to wonder what really happens in the unseen shafts and machinery, hundreds of feet above and below you, that makes this everyday magic possible? When you press that button, you're not directly activating the elevator car. Instead, your touch sends an electrical signal to the elevator's central brain, the control system. This intelligent computer, often located in a machine room, instantly processes your request alongside any other calls, calculating the most efficient path to pick up passengers and deliver them to their destinations. This intelligent computer, often located in a machine room, instantly processes your request alongside any other calls, calculating the most efficient path to pick up passengers and deliver them to their destinations. Once a route is set, the control system activates the powerful electric motor. This motor, usually found at the top of the elevator shaft, or hoistway, doesn't just pull the car directly. Instead, it turns a large grooved pulley wheel, called a sheave. Around this sheave are looped multiple strong steel cables. One end of these cables attaches to the top of the elevator car, supporting its entire weight. On the other end of these very same cables, an equally heavy object hangs, the counterweight. This is one of the most ingenious and often unseen components. The counterweight is roughly equal to the weight of the elevator car when it's half full of passengers. Because the counterweight balances most of the car's load, the motor only needs to exert a small amount of extra force to move the car up or down, making the system incredibly energy efficient. As the sheave rotates, it simultaneously pulls the car in one direction and the counterweight in the opposite direction. Both the car and the counterweight ride along rigid steel guide rails that run the full length of the hoistway, ensuring smooth, stable vertical movement and preventing any sideways sway. Both the car and the counterweight ride along rigid steel guide rails that run the full length of the hoistway, ensuring smooth, stable vertical movement and preventing any sideways sway. Throughout this journey, sensors continuously monitor the elevator car's exact position and speed within the shaft. They feed this real-time data back to the control system, which precisely adjusts the motor's speed and power. This allows for smooth acceleration and deceleration, ensuring you barely feel the transitions as the car glides to a stop perfectly level with your floor. But what if something goes wrong? Elevators are one of the safest forms of transportation thanks to multiple redundant safety systems. A governor, a speed sensing device, monitors the car's velocity. If it detects the car exceeding a safe limit, it triggers powerful safety brakes, clamping mechanisms that grip the guide rails and bring the car to a controlled, secure stop. Additionally, giant buffers at the bottom of the hoistway act like shock absorbers in the unlikely event of an over-travel. So the next time you ride an elevator, remember it's not just a box moving up and down. It's a complex, perfectly synchronized dance of power, balance, and precision engineering that happens silently behind the walls. This intricate choreography ensures your effortless journey, making a seemingly simple daily act an engineering marvel of safety and efficiency. How many other hidden systems silently shape your world every day?